and welcome. This is Computer Science 2. I'm Dr. Chris Burke, and I'll be your instructor for this semester. I've got three offerings of this course, but this is CSCE 156 in particular. Usually my voice carries, so I don't have a microphone, but if you can't hear me in the back, just say something and I'll try to speak a little bit louder, or I'll go ahead and convert over to a microphone. This is just day one, so we're going to do a course introduction and maybe get into a little bit of an introduction on the actual material. But otherwise, if you want to, you can always ask a question by raising your hand, or if you are following along on YouTube, then you can go ahead and post something to the chat on YouTube. I periodically take a look at it over there. So first of all, we're going to give a course overview, and then we'll get into this course schedule, and then the project that you're going to be doing for this semester. So what is this course all about? Well, it's called Computer Science 2, so it's a natural progression from Computer Science 1. At the end of a Computer Science 1, a CS1 course, you should be able to approach a reasonably complex problem, design a top-down solution, and code that program in a high-level programming language. That means that you should be able to take a problem and you should be able to break it down top-down, break it down into smaller and smaller chunks until either that's one piece of code, one line of code, or a function call to a standard library. And then by putting all these pieces together, you've solved the full problem itself. The key realizations that you should have coming out of a Computer Science 1 course are that computer programs are not problem solvers. Computers don't solve problems. Not even the modern AI solves problems. You're the problem solver. Computers are dumb. They only do exactly what they're told to do. There are no ghosts in the machine. There is no true AI yet, right? Programs that you write only automate solutions, right? Computers are very good about doing lots of data very quickly. Humans are not so good about that. But computers are terrible about solving problems, something unique and new. So by the time that this is a quote by Douglas Adams, I think. By the time you've sorted out a complicated idea into small little steps that even a stupid machine can deal with, you've certainly learned about something about it yourself. In other words, by following this process and programming, you've solved the problem. You've become the problem solver. What's the difference between that and going into Computer Science 2, this course? By the end of this course, CS2, you should be able to approach a reasonably complex problem, and instead of designing a problem top-down or of a solution top-down immediately, you ask questions first. Design questions. What entities or objects would be appropriate to model this problem? How would these objects interact to solve this problem? And what data structures could I just pull off the shelf to make this problem trivially solvable? Oh, I recognize that as a graph problem or a problem that I could just use a queue for or something like that. It's a fundamentally different approach to problem solving. It's bottom up. You start down here and start asking these questions of what components do I need first, instead of breaking the problem down and then getting those components. And here's a quote that encapsulates that from Eric S. Raymond, that smart data structures and dumb code are a lot better than the other way around. By the end of this course, you'll understand that. You can write really complex, clever code, right? That's really clever code, the opposite of dumb code. But it's much smarter if you go with clever data structures and dumb code. By the end of the course, we'll look at heap sort. Heap sort simply just puts stuff into a heap and takes it out. And when it's out, it's magically sorted, right? Smart data structure, dumb code, put stuff in, take stuff out. It doesn't get any simpler than that. But the heap solves all of your problems because it's a data structure, right? It's a smart data structure. Here's our approximate schedule. For the first 3 weeks, we cover Java. If you already have Java experience, great. Then this will just be reinforcing it. If you don't have any Java experience, that's fine too. The prerequisite for this course is a Computer Science 1 course, which means that you are competent in at least one programming language. Whether that's Python, C, Java, C#, whatever, doesn't matter. We'll be covering Java. For the next 3 weeks after that, from week 3 on to 6, we'll cover object-oriented programming in the context of Java. There are lots of object-oriented programming languages out there. Many programming languages support certain aspects of object-oriented programming, and I will draw distinctions between those as we go along, but we will focus mostly on Java. After that, we turn our attention to databases and SQL, structured query language. That's a different language that's used on databases, relational database management systems, in order to query data in and out of that database. We then turn our attention to data structures and algorithms, covering list-based data structures, algorithms and algorithm analysis, searching and sorting, stacks and queues, and then we end with basic binary search trees, or binary trees, and heaps at the end. Right? So that's our 15-week schedule, minus 1 week in there. I'm not counting spring break for that. Right? So we do have a full 15-week schedule. The way that you are graded in this class is on labs and assignments. There are no quizzes, there are no exams, nothing like that. It is all 100% your own work, right? The labs consist about 20% of your grade. There are 14 labs total. Note here down at the bottom, the lowest one is dropped, so that means 13 labs, each one is 20 points. That's 260 points, whatever that comes out to, about 20% of your grade. Generally, each week you will be given starter code that you clone from GitHub. And then in the lab sessions, it's in person, sorry, not Zoom, right? There are no longer any online sections for this course. But if you want to work with a partner or if you need help from an LA, we will team you up. We will be taking attendance, but that's just to track a performance. We will not be grading on attendance. There is a very strong correlation between those who show up to lab and do the work there and get help, and those who don't, versus those who succeed in courses and those who don't. So I will strongly, with the utmost strength of my recommendation, make sure that you're going to the lab at least for the first half of the course. All right? Don't just blow it off. It can be completed asynchronously. If you want to get started on the lab beforehand, that's fine. They're all up and available and running. Right? The way that labs are graded are based on completion. You will have these, what are these called, JUnit tests. If you've done unit testing in Computer Science 1, great. If you haven't, then you'll be doing it here. In the context of Java, we use JUnit. You just hit a button and it runs all of these automated tests. 1 test, 2 tests, 100 tests, it doesn't matter. They all have to pass. If they all pass, you hand it in, great, you get your 20 out of 20. If 99 of them pass and 1 fails, you got to go back and make sure that you're doing it. You have until midnight on Wednesday. That Wednesdays are when the labs are for this course. You have all the way till midnight to fix your issues. Once midnight hits, though, the submission is closed. So make sure that you are passing all of your tests. Okay. The assignments are 80% of your grade. Assignment 1 is where we get started, and it is 3 basic programs in Java. There are no partners, there are no collaboration, there is no use of AI tools at all on any of that. You need to show that you actually meet the prerequisites for this course, that you're competent in at least 1 programming language. You should be able to do all 3 of these basic programs in the language that you know, whether that's Python or C or whatever. Those coming from the 155E section from last semester, you've done all these programs before in C already. So all you need to do is learn how to do them in Java. Right? Again, there's no partners, no collaboration on the first assignment because you need to show that you're ready for this course. I would highly encourage you to take a look at the assignment today to see what the problems are, and so that you can start thinking about those problems. Otherwise, assignment 2 through 7 focus on a semester-long project. The first phase has you doing basic EDI, which is electronic data interchange. You will design objects and then interact with a bunch of files and convert them over to JSON or XML or something like that. Then you will build on that in the second phase where you design this application and implementation to produce a bunch of reports. The context changes every single semester, but this semester is that you are writing a sales system for a regional wireless company that has a bunch of wireless stores, and they sell cell phones and cell phone accessories. They lease and sell cell phones. They sell plans, data plans and voice plans. Then you'll design a database to support that business model. And then you'll use that database. Instead of loading up from a bunch of files, you'll load up from the actual database, write stuff back to the database. That's what persistence is. And then you will design a list-based data structure and integrate it into your project. Each one of these is about 2 to 3 weeks between them, all right? And then assignment 8 is all written. It's theory, data structures, and algorithms, because that's where we are by the end of the semester. It's a multi-phase themed project. Again, the theme this semester is a wireless retail system. And each phase is graded based on correctness and design. There is a little bit for documentation and style. Those need to be there, but those should be automatic by the end of this Computer Science 1 course. With each one of those phases, you will be maintaining a living design document. A design document will be maintained and updated. It will be due 1 week prior to each phase being due. The intention here is that you are going to write out your design to give you a head start on thinking about how you should approach that particular phase. But also we're going to give you feedback, and we're going to say, that doesn't look right there, or we're going to anticipate a problem with you doing it like that. If you give us a good living design document on each phase, a design draft, then we'll be able to provide good feedback, and you'll be able to head off problems before they become problems. Drafts are part of the grade, excuse me, but only the final draft's contents are graded. What that means is that when you hand in a draft, there will be, of course, 6 or 7 phases here, so there will be 6 or 7 drafts. Each draft is graded based only on, you handed it in, great, you get the points for that draft. Only the last draft is actually graded based on its content, based on whether or not it is a coherent document, based on whether or not it gives an accurate portrayal of what your design is. Of course, we will be providing more details as we go on through the semester, but you are expected to follow an IEEE template, which we provide. We provide a Word template and a LaTeX template if you know LaTeX or if you want to learn LaTeX. Otherwise, just use Word. Right? For the projects, not for assignment 1, but for the projects, assignment 2 and beyond, it is highly recommended, in fact, we highly encourage you to work in pairs. Teams of 3, 4, 5, definitely not, right? You can work alone if you want to, or if you insist. You can change your partner, right? From one phase to the next, if that partnership is not working out. But beyond your partnership, you may discuss at a high level with other teams, but all work has to be original, right? When you partner up, if you choose to partner up, it has to be an equal amount of work. It's not you do phase 1 and I'll do phase 2, or you do this part and I'll do this part of that phase. You need to bounce ideas off of each other. You need to be working together either in person, right, side by side, or at least you need to come together at some point to discuss your design, to discuss your implementation. We really highly encourage you to do this because it helps you develop those soft skills. I'm not a firm believer in it, but there are folks that say that you can't teach soft skills. It's just something you have to learn by experience. And to a large degree, that is true. Communication, teamwork, conflict resolution, right? What happens when you're doing all the work and your partner is slacking, not doing anything, right? That's conflict resolution. You need to be able to have that tough conversation with your partner of, I need to see you at the next meeting, or I'm going my own way and this partnership is dissolved, right? That's the type of thing that can happen, so be careful. Because partners can mooch, they can flake out, they can disappear. It happens every year, right? Choosing to work in a pair means that you're not only responsible for yourself, but now you're responsible for somebody else as well, right? And you're responsible for each other. If you do choose to team up, make sure you're using Git. It's 2024. There's no excuse for handing back files over email or a thumbnail drive or anything like that. There are details on how to do this in the handout, but make sure that you're pairing up on Canvas if this is how you're doing it, because our automated grading system will look at Canvas, who's paired up. Okay, that's one assignment. We're grading one assignment, right? You might both hand in a copy, but we're only grading one, right? So make sure that you are pairing up on Canvas. And like I said before, the use of any AI tools, ChatGPT, Copilot, whatever, is prohibited. Right? The keys to the success of this course are take the long view. Right? It's a semester-long project. You need to understand where we're going and where you are, and so I would encourage you to start reading the assignments now, reading that first assignment. Another key is starting early, or at least starting so that you pace yourself. One tool that we have to help you with that is called I need to bring it up. Assignments for spring 2024. Nope, okay, so it's probably it's already on GitHub. Let me pull it up here. Assignments, there we go, and here we go. This is called when it comes up, a Gantt chart. A Gantt chart is a way that you can help organize and schedule a project. I've already provided the first half of this course for you. This is a Gantt chart in Excel. So, for example, what should you be doing today, tomorrow, and the next day? That is the 22nd through the 24th. You should be reading and understanding the handout for assignment 1, right? Once you've done that, you can mark yourself down. Yay, I've done that. I'm 100% confident that I understand what I'm doing with that assignment, and I'm ready to proceed, right? On Lab 1, which is on Wednesday, once you're done with that, go ahead and mark that as 100%. And you see how this has been scheduled throughout the semester, right? This is just my estimation. This is my direction of, well, it should only take you 2 days to do that. If it takes you 3 days, fine. Go ahead and update it to 127 instead. And it advances everything further, right? Undo that. If you, that's only going to take me 1 day. I can do that right now and be done with it, right? And just mark it as 100%. Everything advances or everything shifts automatically because it's in this Excel file, right? This is a way for you to self-organize and organize with your partner if you choose to partner up with somebody eventually later on. It is much better to spread the work out over the next 3 weeks for assignment 1 than it is to wait and have all of these little areas here all due on the last day, because that ain't happening. Assignment 1 is not complicated, but it's complicated. It's too complicated for 1 day, right? There is no such thing as cram when it comes to programming, when it comes to design, stuff like that. You need time to think about things, and you need time to digest things, right? You can't just cram a bunch of facts the day before the exam, because that's not how this works. We don't have exams like that, right? So I will bring your attention to this throughout the semester, both in class and on Piazza. If you don't want to use this, if you've got your own system, great, go ahead, use it, whatever. Right? You're not going to be handing this in. This is not something that is due. This is not something that is graded. It is a resource for you, right? If you found that you kind of struggled with self-discipline, self-organization in Computer Science 1 or whatever, here's one option for you, okay? A Gantt chart, G-A-N-T-T, and that's available on GitHub already. In fact, let's take a look at Canvas here. There it is. There's the link to it, along with the syllabus, which we'll get to in a second. Week 1, right? Design your own test cases before coding. That's also built into the schedule. Use proper debugging techniques. I do have a couple of videos on how to use the debugger in Eclipse. Otherwise, I've got videos on how to do debugging in general. Hopefully, you've done debugging, I don't know, with Python, whatever IDE you used, PyCharm, whatever has a built-in debugger, et cetera, right? Remember, the idea of this course is that smart data structures and dumb code are a lot better than the other way around. That takes a different type of mental thinking than the top-down approach that you're used to in Computer Science 1. It takes more time of thinking, less time coding, right? Or at least that's the way it should work. Be aware of technical debt. If you don't have time to do it right the first time, then you're going to have to find time to do it over, right? If you have a bad, remember these are phases that build on each other. If you have a bad design in phase 1, you're going to be eating your own dog food in phase 2, phase 3, phase 4, unless you go back and fix it, right? Or if you just put in more effort, or not effort, but more thought into the design up front first, got feedback on it, then you won't run into those problems. You won't have technical debt. Technical debt is a loan, right? You've taken out a loan, not in money, but in time, future time. Either you're going to have to find time to do it over later on, and you do it really, really quick and you just get it done, right? You didn't put much thought into it. You didn't put much design into it. Well, guess what? You've taken out a loan and you're going to be paying interest on that loan later on, right? That's why we call it technical debt. Ask questions. Attend to help hours early, right? You will find that everything is due on a Friday. All the assignments are due on Fridays for this course. You will find that that is the most difficult time to get help. Why? Because a whole bunch of other people have waited till the last possible minute to ask questions, to get started, whatever, right? And now the Student Resource Center, or the Lab 15 where everything is held, is now full, and you're not going to be able to get help. So ask LAs for feedback on your design in their regular help hours throughout the week. Right? Otherwise, we've got several course resources. Everybody should be familiar with Canvas already. There it is. In the front page, I've got everything separated out by weeks, including topics that we're going to be covering that week, the lab that's due that week, and other materials, as well as any assignments that are due. You don't have any assignments due until the third week, right? But that doesn't mean that you shouldn't be taking a look at the assignment and thinking about it. And in fact, maybe in the first week, you do the simplest ones first, right? There are three exercises here. The first one is just a basic input-output, which you should be able to do by the end of the first week here. So just get it done, right? Then we've got Module 2, which is object-oriented programming, databases, database design. There's Spring Break. That's not Spring Break right there. Spring Break has no listing. This is the week after Spring Break, where we cover, then after that, we cover list data structures, algorithms and algorithm analysis, and trees and tree-based data structures. You will notice here that throughout the semester, I've got pre-prepared videos. Not in the first, well, actually, no, I do, all right? Quick Introduction to Java, videos 1.1 through 1.13, right? So those are supplements to lecture, right? Several years ago, I put these together, and it walks you through Java. If you want to work ahead, great, go ahead and do this. Still come to the lecture, right? Show your pretty faces out there, right? Otherwise, we've got Piazza as our primary means of communication. You can email me. You can email me a question, but I'm going to say, great question. Let's take that over to Piazza. Why? Because everybody gets the benefit of the answer. Here's what it is. You should have received an invite to it already to your Huskers account, or whatever account you've got on Canvas. Every week I've got retrospectives. Every week I've got, at the front of every week, I've got what we're going to be doing that week. For example, Lab 1, there's a link to it. It's due on Wednesday. One of my videos, video 0.1, is a complete walkthrough of that lab. If you want to get it done today so that you can have some extra time on Wednesday during lab to ask other questions or get other things resolved, go ahead and do it. It's an introduction to the process of grading. You'll do a basic Java program that we walk you through, and then you'll hand it in, you'll run the web grader and see, oh, great, I've got all my test cases passed. I get 100% on that lab, right? Let's see, what else? I guess that's Piazza. You can ask questions anonymously. You can ask questions privately. You can ask questions so that we know who you are, the instructors know who you are, but your fellow students don't know who you are. So in other words, there's no embarrassment. You can, other students can answer your questions, right? Don't post code to Piazza in a public message, of course, but you can ask questions there, and usually I think the average turnaround time is usually like 10 minutes, right? We will be answering questions over the weekend. We will be answering questions at night. Not too late for me. I go to bed at 9, get up at 5, but you might see something early answered, right? Okay. Finally, GitHub. Lots of the Canvas page is just a front-facing interface for everything. Everything is actually hosted over here on GitHub. If you want to go to GitHub directly, that's fine too. For example, here's the syllabus. Dark mode okay for everybody in the back? All right, if not, I can at least increase the size here. Right, there we go. All right. So there it is. There's our theme for the course. Smart data structures and dumb code are a lot better than the other way around. The prerequisites, for some reason, are still calculus. You don't need calc for this course. We won't be using calculus or derivatives or anything like that. Instead, it's just a basic mathematical maturity. You should be a sophomore at least. You should have taken calculus at some point. You should have a mathematical maturity equivalent to that. And a C or better in Computer Science 1. If that's 155E, 155T, 155A, 155N, any of those will work, right? Why? Because those cover different programming languages. We'll be covering Java here. Otherwise, university policies, resources and services, including services for students with disabilities, accommodations, things like that. Make sure that you're taking a look at that UNL clearinghouse for all those things. Otherwise, you can read through the learning objectives and skills for this course, et cetera, et cetera. The tentative topics, which we've already talked about. A continuation of instruction if in-person classes are canceled. Doesn't look like the weather will turn bad anytime soon again. But if so, I might live stream. I'm live streaming right now. I might live stream from home instead, right? Otherwise, there's the assessment, right? You start free starter points here just so that it comes out to an even number. Labs, 13 of them, each worth 20 points. There's 260 points. Assignments, 9. 9 assignments. There are 7 actual assignments, then the 8th written one, and then the 9th one is actually your design document. All those total, they're not all equal. Some are more because it's more work. Some are less because it's less work. Right? There is a standard letter grade for you. Again, everything that I just said about labs, they're on Wednesday. They're due by midnight. All of your tests have to pass, or none of them, or it's like none of them do. Right? And it's all automated, by the way. The next day on Thursday, I will run a script. It will run all of your tests for everybody in the entire class, auto-populate Canvas, and then I'm done. I post a report on it, and then I'm done. Right? It's not like somebody is sitting there looking at your lab. So we don't grade on style, documentation, or design in labs, only correctness. Otherwise, there are assignments. They are due at midnight, 1 second before midnight every Friday. They are due through the web hand-in, so make sure that you're handing those in. Otherwise, it'll just close out and not let you hand it in anymore. Those are all Central Standard Time, which is whatever we're on right now. Right? Again, we've provided a Gantt chart with a recommended schedule of work, so that you're not doing everything right the day before it's due. You're pacing yourself right throughout the 3 weeks or 2 weeks or 1 week, whatever the assignment calls for. If you have any questions on grading, make sure that you direct them to the person who graded it first. You'll know who that is by looking at this tool that we use called CodePost. More details on that later on. Right? Otherwise, no late work is generally accepted. It's got to work through the web grader. If it doesn't compile, if it doesn't work, then there's nothing that we can do about it. There's nothing that we can grade. So make sure that the grader feedback, that you're looking at that you're paying attention to it, that you can go back. You can hand it in as many times as you want. Go back, fix your issues, hand it in again. Hand it in 50 times, 100 times, 1,000 times if you want. Right? Up till that due date. Up to that due date. Once that due date passes, no more handing it in. It locks you out. So make sure that you are fixing everything, and you are only able to fix stuff if you've given yourself enough time to fix stuff. So start early. Again, academic integrity, make sure that everything is your own. If partners are allowed, great, adhere to the partner policy. If partners are not allowed, don't team up with anybody. And the use of any AI tools for the design or implementation of anything in this is strictly prohibited for this course. Those tools have their place, right? They don't have their place in learning something for the first time, right? If you just use an AI tool to design something, you never understand. First of all, you're not able to discern whether or not it was a good design. We'll tell you whether or not it did generate a good design if you are cheating like that. But otherwise, you need to learn something before you can use a tool like that. Right? The best way to talk to us is through Piazza. Post privately, post anonymously if you need to. If you are going to ask a question about, can you take a look at my submission? Don't post anonymously, right? Because we're just going to say, who the hell are you, right? And make sure that you're, and then you'll have to post a follow-up. Here's who I am, right? And then it delays our answer. But otherwise, there's also an anonymous suggestion box. This is a School of Computing anonymous suggestion box. So beyond this course, if you've got a suggestion for the School of Computing, if you've got a complaint about the School of Computing, and you can identify yourself there if you want to, but otherwise you can send an anonymous suggestion to the chair, or the director now is what they're called, and the appropriate people. And generally we do get suggestions every so often through that box, and we do pay attention to them. Otherwise, we've got a learning assistant program. Many of you, especially if you went through 155A or E, or I believe N is also on the program, we have a learning assistant program. If you take a look at Canvas and go all the way to the top, look at the very first link, getting help and instructor info, right? We have got, 50, 60 help hours throughout the entire week. For example, right before this class, Adarsha, I think that was, held her office hours 9:30 a.m., right? She was available over in, everything is over in Avery 15. Right after this lecture, you can go over there and talk to Umarov, right, if you need to. Otherwise, we've got help sessions throughout the entire week. Obviously, they don't conflict with lab. They don't conflict with lecture. Right? If you've got on lab days, where should you be going for help? The lab, right? Otherwise, there I am. I hold my office hours also in Avery 15. That is not the Student Resource Center. That is over in Avery basement, room 15. I hold 2 hours every week, Mondays and Wednesdays, right? Otherwise, we've got a dozen learning assistants to help you out if you need help. Right? There they all are. You can read all about them and learn what their hobbies are or whatever. Right? We've also got people in the Student Resource Center. Most likely, they'll be able to help you, but primarily they're going to send you back to Avery 15 for help from the learning assistants for this course. You also, if you need it, you can go to study areas throughout the campus. You can reserve rooms over in the Adele Commons, I think it is, wherever Dunkin' Donuts is, and use those study areas for to work with your partner or to work on a lab or whatever. Right? All right. The textbook for this course is a free and open source textbook. You don't have to pay for it. It's mine. Throughout the semester, if you take a look at I don't have chapters on Java. I don't have chapters on object-oriented programming, but I do have chapters eventually on databases. So what I suggest you do when we get there is to read Chapter 3 on Computer Science 2. It's just a PDF, right? It's not an interactive textbook like, say, Zybooks that you might have used in Computer Science 1, but it is free, open source, etc. I also have videos on it, right? So your textbook, the textbook and the YouTube videos are plentiful resources for this course. Otherwise, the course webpage, we already looked at the schedule, help hours and learning assistance and labs. And then we also went through the syllabus and policies and the Gantt chart. Any questions so far on resources for this course? No? Okay. Then more resources are available here. We'll talk about them as we go on. You'll be introduced to the hand-in, the WebGrader, and the CodePost later on. Right? For those coming from 155E, we use CodePost for everything. We are not using CodePost for everything this semester because it does not support half of the stuff that we do. Instead, we're using my personal web hand-in WebGrader. All right, there we go. So let's get started. We're talking about Java, right? So what is Java? Well, Java is a programming language. It's not a very old programming language by programming language standards. It was created in 1995 by, darn it, do I have his name here? I forget who he was, but whatever, who cares, right? It is now, well, I guess 30 years old, right? It is, oops, sorry, that's really small. Let's go large there. So Java is a class-based or object-oriented programming language. What that means is that everything in Java is either a class, and that is a keyword in Java. Oops, sorry. And that is a keyword in Java, class is. You'll create classes and use classes. Everything in Java is a class or is inside of a class, belongs to a class. What is a class? Well, a class is simply a unit of code that's declared. Right? For example, if I were to create a Hello World program and call it Hello World, no spaces allowed. Even if spaces were allowed, it's a bad idea. Whenever you create a file, never put spaces in it. If you need to space it out, put underscores in it or something like that. It would be in a file called helloworld.java. In fact, let's do that right now. Lab 1 will walk you through the installation and creation of what we're about to do here. This is called Eclipse. Eclipse is an integrated development environment, an IDE. Everything that you need to write and test and hand in programs is right here in Eclipse. If you've used a different IDE in the past, JetBeans or NetBeans, what else is there? IntelliJ, et cetera, feel free. Go ahead and use it. None of the instructions will support those other IDEs, though. So if you're using those other IDEs, you need to know what you're doing, right? And you need to know how to do it in those environments. I'm just going to go ahead. I've already created a project here, but let's go ahead and create a new project. And I'll call this project, Java project here. I'll call it Hello. I'll just call it Hello. right? I only have Java 17. I think we're up to Java 21. If you download Java, the most recent SDK, the Standard Developer Environment, or JDK, then it'll probably be 21. We're not going to have too many issues with Java versioning. Just go ahead and download the latest version, the latest fully supported version. It looks like I do have 21 available. I'll just go ahead and go with 17 here, though. This will be clicked by default. When we go through your lab, make sure we will tell you why you don't want that clicked by default. Make sure that you're unclicking that, right? And I'm just going to go ahead and finish this. That creates a new project here. That actually, what that does is it creates a folder and a bunch of other subfolders on my hard drive right here. So somewhere on my personal computer here, I've now created a folder called Hello. It's got a bin folder and a source folder. Well, what is bin for? What do you think? Well, actually, what is SRC for? Not Student Resource Center. It is the source, right? All of your source files are going to be placed into this directory. When it gets built, this is binary. Everything that gets built is going to be put into this library. You don't have to worry about any of that because the IDE takes care of all of it for you. You should be interacting only with this IDE, this integrated development environment. I'm going to go ahead and create a new package, unl.soc. Why UNL? Because that's where we are. Why SOC? What's our academic unit? School of Computing. Right? So let's go ahead and finish that. Hey, on the IDE, it creates this thing called unl.soc. Over here on my hard drive, what has it done? It's created a folder called UNL and a subfolder called SOC. A package is nothing more than a way to organize code in directories and subdirectories. So that if you've got code that pertains to math, you'd put that in the math directory, into the math package, etc. Right? Now let's go ahead and put let's create an actual class now. And I'm just going to go ahead and go new class. And I'll call mine Hello World, just like I did, world, just like I did in the notes that I was writing up here. By the way, these notes will be posted to GitHub on a daily or at least weekly basis. I will post a link to them directly when at the end of this week in our retrospective, right? Otherwise, let's go ahead and create a Hello World class. Finish. There you go. That created a source file. If you read it, squint your eyes up here really hard, helloworld.java. Again, let's take a look at it over here, helloworld.java, right? And over here in the bin folder, now I've got unlsoc helloworld.class. That .class file is a binary file. It's not something that's intended to be read. If I drag and drop this over here, I wonder what happens actually. There we go. It is not showing any of the binary, but it is showing what it can show, right? That is a class file that is compiled for the Java virtual machine. The Java virtual machine is already installed on my computer, and when I hit this play button up here, it'll actually run this program. The problem is, I haven't written anything in my program yet. I will draw your attention before we do that, up here to this package declaration. Where did I put this? unl.soc. That package declaration needs to be up here. If it's not, or if it's misspelled or something like that, that's a compiler error. A compiler error is highlighted with the underlying red mark here. And if you hover over it, it tells you what the problem is and gives you a couple of solutions here. Well, the solution here is to spell it correctly and not do that. Right? Now I've got my public class Hello World. Remember, everything in Java is a class or belongs to a class. So Hello World here is my class. If I misspelled that with a capital O, that's also a compiler error, right? Why? Because Hello World with a capital O does not match Hello World with a lowercase o here. No spaces, right? Generally, you have to spell it out correctly all over the place. Hello World, right? There's a Pythonic way of labeling a package of some sort, right? That's not the style in Java. In Java, everything should be upper camel cased. Hello World, excuse me, where the first letter of every word is uppercased. All of the letters after that are lowercase, and then there's no spaces. That's the way you do it in Java. You can create classes with lowercase letters, but you shouldn't, because that's not the Java way of doing it. If I were in Python, I would be doing that, but maybe I forget what the PEP says on that, but whatever, right? All right, let's actually do something now. If you were to run a program in C, where is your starting point? So to compile something in C, for those with a C background, what did we do? We needed a main function, right? In Python, what do you need to do? You can have a main function, something like looks like this, main something, I forget the exact syntax, but you can have a main in Python, and that is what will be run. Otherwise, in Python, you just start running, right? Whatever you've put into your script file, it goes top to bottom. But in Java and most programming languages, you have to have a starting point. That starting point is going to be the public static void main function. Right? And I'm just going to write it like this, string args. These are command line arguments. If this is too small, I can always increase it for those in the back. There we go. Big enough? Yes? Anybody in the back? All right, good. Now, if I were to run this program right now, if I didn't put that, let me show you what happens when you don't have something like this. This is not an executable program. It's a class. I can put functions into it. I can put methods into it. I can put variables into it, but it ain't going to do anything. Sorry, that's something else, right? If I want to run this program right here, that's something else. It's not even going to recognize this, right? Like, this is not a runnable program. The second that I put my main in there, now it's something that can be run. There we go, run it. But of course, did it do anything? No. Why? Do you see any code inside that function? No. So let's put some code into that function. If you were coming from a C background, how would you print hello world? Printf, hello world. Right? What is that backslash or a forward slash? Remind me. Is it a backslash or a forward slash? What's the trick for remembering that? You stand and you face the direction that you write. Are you leaning forward or are you leaning back? That guy's leaning back, so it's a backslash. That'll go to the next line. If you were in Python, how would you do this? Obviously, that's not going to work, right? Because it's red mark right there. Python, how do you print hello world? Python 3, hopefully you did. Yeah, go ahead. Hello world. How do you go to the next line? Exactly. Oh, you're right. Print automatically does that, right? What's the difference here? Over here in C, what did I do? Semicolon. Over here in Python, what's at the end of every line? Nada, right? So there is familiarity right there. In Java, it's going to be a little bit different. You want the standard output of the screen, you need to go system.out. That's the standard output. Dot print F, let's say, hello world. There we go. And forget about the rest of that stuff that was auto-completed, right? Printf, that works. If you use printf style placeholders, they will all work, right? There we go. So almost exactly the same, except that it's preceding a system.out here. Let's do another one, system.out.print. You can do that as well, hello world. There we go. What's that going to do? Hello world, because there's no end-line character there. So let's do another one. System.out.print ln hello world. There we go. Now it's invisible, but that one did in fact go to the next line. Let me show you. I'll transpose those two lines of code, and you'll see that it automatically inserted the end-line character. Why? Because I call the version with ln. What do you think ln stands for? Line. Print on a line, hello world, so that you don't need those end-line characters. But you should have those end-line characters if you need them, and this will print out hello world on 3 different lines. Lots of different options there. We'll get into them later on. This is obviously a string. In C, double quotes. In Python, you can do double quotes or single quotes. That ain't the same in Java. Single quotes are for single characters, not strings. So that is something that you'll need to get used to if you're coming from a Python background. Right? Double quotes are for strings. Single quotes are for characters. For example, if I create a character here, there we go. I can do something like that. Okay? You will find that the vast majority of things that you do in any programming language, whether it's Java, C, or Python, they're going to have almost a direct translation. Printf, print, right? Those almost have a direct translation. It's just tiny, subtle differences. The other thing that I'll draw your attention to, especially if you're coming from a Python background, is those semicolons. In English, we end every sentence with a period, or an exclamation point, or a question mark, right? In coding, at least in static languages like C, C++, C#, Java, et cetera, we end them with semicolons because it's much easier on the compiler. In Python, actually, you can put them in Python. They won't do anything. They'll be ignored, but you can put them there. Right? One last difference that I'll show you here is every time that you write a program, make sure that you are documenting it. This is doc-style comments here. That is, all I did was /*, and then it has a bunch of vertical stars here for me. Author, Chris Burke, date 2024-01. Today is the 22nd. That is the only proper way of doing dates, by the way. It's lexicographically orderable. Europeans get it wrong. Americans get it wrong. The only people that get it right are us, right? The ones that do it lexicographically, so we don't have to worry about sorting. Right? Otherwise, give a purpose. This program prints hello world to the standard output. Yay. Right? This is a doc-style comment. If you were in say, Python, what would you do? 1, 2, 3, 1, 2, 3. You can do this in Java too now, but you don't do this as comments. You can do multi-line comments here, and you would have the exact same thing. Author, date, program, whatever. Right? If you were in C, you would be doing the exact same thing as this. Right? This is a multi-line comment that gets ignored. If you want, you can use regular multi-line comments with just a */ and a /*, and then multi-line comment, neato, right? Et cetera. If you want one single line comment, then it's the same as C, // hello world, right? That's different than Python. In Python, how would you do something like this? Hash, right? Hello world. That doesn't work in Java, right? Works in a couple of other programming languages I know of, but nothing, not many, right? So we'll continue there on Wednesday.